Okay, also welcome from my side. As usual, I like to make a quick announcement before we start with the actual talk. For those of you who don't know me yet, my name is Stampar. I work for G-Data, that's an antivirus company located here in Bochum. And we are supporting this course since a few years now, which basically means we are offering an additional evening event every time we have an invited speaker here. And here you can find some of the details on the slide. We will drive over there directly after the talk, and if you're interested in talking a little bit more in detail about the topics he's presenting today, or if you want to get in touch with people working on the technical side of the antivirus community, all of you are welcome to join us. If you have any questions, don't hesitate to come to me after the talk. So I think you can will introduce yourself.
Oh, thank you. Good evening, everybody. My name is Miroslav Stampar, and I'm one of the developers of SQL Map. I already discussed with your colleagues that at one presentation I'm talking about the SQL Map, but at different occasions I talk about totally different subjects. So now it was a turn for totally different subjects. So today you won't hear a lot of about the SQL Map, but about the SQL injection itself. So at this talk, I would like to present you about one case that I've came around a month or two ago, and it was quite curious. I've came across lots and lots of different cases. As you can imagine, we have a large user base with lots and lots of requests and examples and stuff. And this one was totally new stuff for me. So I'm working with SQL injections for the last 5 years. This was something quite new to me. So I wanted to present it somewhere, and now I'll present here. So, about the target itself, I haven't properly introduced myself. I was a software developer for a very long time, and lately I'm a security advisor and penetration tester for one company in Croatia. And we have a lot of high-profile targets. In this case, it was a high-profile target. I changed lots of details here, so you won't be able to pinpoint which was it, but you should just make well, it was a high profile. So at the end, it was very important for my superiors to be secure. So when we started working on it, it first appeared as a flash site. So it had lots of flashy stuff going around, lots of clicking, and there was very little user interaction. So apart from clicking, you weren't able to click anything. So it really appeared as some kind of comic book. My colleagues at the start had run the automatic vulnerability scanners. We have around 4 or 5 different automatic scanners, some commercial, some non-commercial. And apart from usual nagging about the clickjacking being possible or lack of security headers, there was nothing special about it. Used JavaScript libraries were up to date, and those custom JavaScript parts were clean. So when you have looked into the code itself, there are no document location mingling around or some open redirections inside. So at first glance, it really appeared as something that couldn't be broken. There was no user management, so I'm not sure which parts of web application security have you covered, but this information is quite important in penetration testing, just for you to know which parts you need to take into seriously or less seriously. So if there is no user management, or if everybody is anonymous, still stuff like clickjacking or security headers is not so importance. So at the end we put that stuff into the report itself, but we don't make the importance toward them. Only attack points that were susceptible to malicious user interaction were 2 AX calls. First AX call was the user search. So there was a user search form in the upper right corner, and the other AX call was the search that the application itself was being done below, which filled the page itself. So at the end, it was some kind of news site with lots of news, which were filled with this search called category ISP. So after that first glance into the results of the web application scanners and into the source code itself, the next usual step is to turn the burp and to see what's going on down below. Down below, those 2 requests of interests looked like this. So that first AX call was a post call search ISP. That's not the proper name. That's not the right name. I changed everything so to skew the connections to the real target. But at the end, the content is important here. So there were 2 post calls, post AX calls. This search one had the user text filled here into the text parameter. It had some auxiliary parameters here. So at the end, when you look into this, it seemed at the beginning that something from some kind of directory or anything called content HTML text, in this case was test, was being searched inside it and ordered via some parameters of the file itself. Also there was that extension filter for the HTML and the top part here. So when I looked into it, this part was really quite it was quite nailing into my eyes. So if you know about the SQL, this part is really too obvious. So you have name of one column, probably in column, ascending, then the other column ascending, then at the first glance it really appears like it's SQL injectable. The second call was this one for filling the news site itself. It had those 3 parameters. There was also the folder here, quantity, and the XTN subject. At the end, response looked like this. So at the end, it appeared like some kind of URLs or relative URLs which the application itself took and displayed it to the web UI, into the web itself. And now I would like to present what was the chronology of the whole penetration test, or the first failures toward some successful findings. So at the beginning, first tests real fail. So those first things like trashing of values, tampering of values, whatever, with values like this, resulted in prolonged HTTP error 500 responses. So it was quite cumbersome to test this application, because whatever you tried, there was a 90 seconds timeout after the request itself for response to come back. So each request that I tried, it was quite mind-numbing. But the thing is that this piece resulted in the SQL injection. If you know the roots or basic of SQL injection, you know that there are some basic stuff that if they work, then you know that it's most probably a SQL injection. If we come back to the request itself, thing is that here, if you have put the minus here after the order itself, everything appeared as original. If you have put the here the single quote minus, this part was commented out inside the SQL injectable statement itself, and the order of appearance of those results were changing. So this order would change itself. So those simple tests with that basic minus or single quote minus really resulted with some finding of the SQL injection. But basic stuff like those and 1 equals 1 or 2 greater than 1 resulted in prolonged error responses. So this was quite failing for myself, because this was a high profile target. This was really a high profile target, and it really had some kind of web application firewall inside of it. But I really wanted to test all the possibilities that the attacker itself would do to bypass that firewall itself. So the thing is that trashing of parameters was doing prolonged responses. This basic testing was really resulting in SQL injection, but this basic stuff like this and wait for delay result in some erroneous responses. But the interesting thing is that things like this, wait for delay full bar, resulted with the immediate HTTP response like this one. So at the end, my conclusion was that this was really blacklisted at the web application firewall, and that this resulted into the immediate HTTP response. But it was quite problematic that these cases result in the prolonged delays. So RT pinpointed that there was some kind of web application firewall involved, but there was also something that said to me that I would need to try all the possibilities. Colleagues told me just to leave it, but my boss told me that there is no hurry and I should investigate as much time as I want. One of the first ideas was to write a SQL injection fuzzer to do the monkey test job. Monkey testing is really just that. You write a program that will do the monkey testing. It will just enter some pseudo-random stuff with the rules you want, and you will just do the differentiation of the response itself. And if the responses if responses differ in some way, you can do some kind of you can extract some knowledge from it. So I really thought that if I wrote some kind of SQL injection fuzzer winning combination of thrashing parameters which won't result neither in 500 response nor either in the delayed 500 response. That was the end of the first day. As a SQL map developer, I wanted to test it both with SQL map, but the problem was those huge delays were really problematic for SQL map to be done in the real time. So I was just leaving it over the night in hope that something will turn out. Turned all possible boundary payload combinations. With this combination, you will generate around 20,000 requests from SQL map. So this is a quite huge test coming out from SQL map. I was really in hope that something useful will come out. During the commuting, I do lots of commuting to work and backwards. I spent 2.5 hours each day, and I do lots of thinking when commuting. In this case, I thought about all the web application file bypass tricks, all non-ASCII SQL payloads, non-disclosed SQL injection attacks, non-mainstream SQL statements and stuff like that. Things that I just wanted to collect to summarize all my knowledge, so I could come back to the day 2 and just to try those that stuff. So at day 2, I try literally everything I could imagine, or everything I could extract from my knowledge domain. There's lots of delayed responses. SQL map was still running, so it was like I left it over the night, so it was like, I believe, 16 hours working. It was still running. Nothing was found. Almost quit and had a hard look into the original request itself. And that ascending, that clause, SQL clause, really was provoking as hell. Then try to Google in hope that something will turn out. And this is the chronology of my Googling. In the beginning, I tried the first column name in hope that something will come out. Nothing special was here. I really went through all the findings. Nothing special than the fact that the system file extension is the property of the files itself on the Windows operating system. Then I tried to find maybe some ISP file would come out with some source code inside. It did, nothing was found. Then I tried to find this combination. There was really nothing going on. And at the end, this was the winning combination. So those two column names with the SQL resulted with this. And I stumbled that the Windows search itself can be SQLed. So it was like stupid face. I was like grinning. I thought that I could really make some work here. So Windows search really can be SQLed. That language is really crippled. It's called advanced query syntax. It's everything but advanced. Thing is that what it does, users can limit the scope of their searches to specific folder locations or data stores. this was exactly what the web administrator was doing. So also I tried to find if there is one single report of the SQL injection for the Windows search, and there was none. This was the basic skeleton of the Windows Search SQL, how you made this SQL itself. So it was only a query. It was only a query-based engine. It had only those couple of clauses: from, where, ordered by, group on. Also, when I've searched for the working program which could I run on my environment, where could I test the language itself, I stumbled on the VB-script version. It really looked like this, and I played with it. You can see here there is a 47 lines. Those commented out were really the all stuff that I wanted to see about the language itself. At the end, you can see here that if you do the query itself, so you are querying the connection instance via this, and you are just outputting the results like this. So in this case, you are outputting the folder display name and the file name here in the output. So this is a folder, this is a file name. Good thing about, I had a luck with this one, because I've noticed that if you put the invalid SQL inside, you'll get the infinite loop here. You'll get the infinite loop here. So this was really telling me that administrator was running the VBS version of the search itself. So I think that I was quite lucky to find this one, because I tried this same approach in the ASP itself, and thing is that ASP itself is not doing this infinite loop when the invalid query is being run. So with that knowledge, I tried to make the SQL injection itself, and you can see here a valid SQL injection using the language itself. So into the top parameter, I managed to put here this part which says select top system item path display from system index where system size greater than 0. Things that with this approach, using the top parameter, you could inject whatever you wanted if it's a valid Windows search query. Also in category, you could do it also in the quantity parameter. Also, one thing to mention is that system index is the default catalog for the Windows search. So out of the system index, you won't be able to do anything. So when you are doing the SQL injection here, you'll need to do the injection on the system index catalog or table, whatever you like to be called. That's it. Responses, where suddenly became like this. So at the beginning we had those couple of files. Now we became to get the real files coming from the in this case this is coming from my testing environment. So this is not from the target itself. So at the end of the day, I summarized the findings. Columns that seemed of interest to me were item, folder, path display, file name, path display, file owner. But some columns really had some interesting names like author, comment, computer name, keyword, subject, title. but at the end they were always empty. So you really had to enter the values into those columns, so the search would return something out of it. All in all, nothing special. Then the proof of SQL injection and the complete file listing. So I was really, so I spent 2 days and I found that I have a crippled SQL injection DBMS at the other end. It was nothing cool. And then all of a sudden I came to an idea that there must be a way how to search files with keywords. I mean, it's called Windows search for a reason. And came to home place. This is the preferred way how you do the SQL injection. You read the whole reference manual. So if you will remember anything from this presentation, this should be this should be it. You really need to read lots of reference manuals. Found a special operator called contains. What's so special about the contains? It really emulates the Windows search functionality itself. So this is what the Windows search is doing. It's running the contains itself. So I thought that if by using the contains, there must be a way how to infer the content of files. So inference is you are just trying to do the reverse engineering of the file content. And if you would do the SQL injection like this, if you would strict the system at path display, so if you would put the file name here, you would restrict the SQL injection to that particular file. And if you would put the contains something like this, a Paval card, then you would do the response differentiation. You see, if the response in this case is okay, then we know that this file name contains the keyword which starts with the A. Came back to work at day 3, and then tried to manually do this file inference trick. When I mentioned that I was lucky, thing is that web administrator was running with the high privileges than the usual one. So if he would run the Windows search functionality from the web application itself, the application will be run in most cases with the anonymous credentials. In that case, a Windows search would just not go through the old catalog, but just to the pinpoint to the files which this anonymous user has. But he used the external VBS script, as was the finding from those previous slides, and he used the high privileges, more permissive ones. Then I tried to retrieve all local file names that were accessible by the VBS process itself. I noticed that from those file names, not the file content, but the file names, system directories were missing. Okay, no problem. Then out of rest, I went to the listing and I found these 2 interesting directories. So all them backup. Inside both of those was a web config file. You probably know what's web config file. So if I would be able to retrieve the content, it would be a nice end of the job. So I started to implement the file content inference using the contains, and this is the code itself. So it's written in Python. What it does, it does the recursive finding of all those words. So it starts with the next slide will be more informative. It starts with for example, with the A. It tries for that particular file, in this case this foo-by-all web config. It starts with it and starts with the letter A and says, does that file contain some keyword which starts with A? If the answer is true, then we are starting to do the recursive finding of what are the other letters. Does it contain AA? No. Does it contain AB? No. Does it contain AD? Yes. Afterwards, we start with the 3 letters. And when you come to that, and when you try to all 4 letter combinations, if all of those are false, then you just come back to the last known prefix. In this case, it's head. So this is exactly what this recursive function does. So you can see here this is the SQL injection itself, and here you can see if this was okay, then the content itself will be greater than 0. Otherwise, it will return the 500. It will come to this exception part, and the content itself will stay the blank. So this was the way how you have managed to differentiate true from false responses. At the end, this was the finding. So I was able to retrieve all the keywords from that web config file. This was the most interesting part, where you had the connection string toward the I have changed the database name, but it was a Microsoft SQL Server. You can see here also SQL client. So you had a system administrator connection inside connection string with the most probably the password for the used inside this connection string. So that was a pretty good catch. As said, search process was constrained with the user rights. So it was a good finding that the administrator was using the external ABS script with the higher rights than anonymous. But from all those file listings, those 2 files were the most interesting ones. Of all those other files, nothing was special about them. So at the end, there are no open ports than the port 80. If there would be a Microsoft SQL Server exposed, I would go further. But with that finding, I called it a day and finished the test altogether. And conclusion, if you have a hunch, stick with it. So penetration testing is it's lots of dirty work involved. So we as a team do lots of penetration tests, and there are always people that tend to like tools, and those people that tend to like more than tools. And from recent findings, web vulnerability scanners were really not of a good use. So at the end, I would really like you to pinpoint the necessity of you to be able to get down and dirty when you are doing the web application assessment, because those most critical stuff are really lying below that GUI and stuff. And that's basically it.